In this video, we'll talk about solving trigonometric equations. This is part 3 of a series. And this will be the last of the series. So we've talked about sine, cosine, tangent, and cotangent at this point, and talking about multiple solutions when we're solving for trigonometric equations. That only leaves us with two that we haven't discussed. We haven't discussed secant and cosecant. And really, they both are very similar, but with one you'll use sine and one you'll use cosine instead. So let's go ahead and jump right into an example. If we're looking at this, we're saying secant of theta equals 2. Now, we don't have a button for secant on our calculators. However, we do know that secant is 1 over the cosine of theta. So we could rewrite this as 1 over cosine equals 2. Now, we need to try and solve for theta, so probably the first step would be to multiply everything by cosine of theta. So we're going to have 1 equals 2 times the cosine of theta, which then we can divide by 2. So cosine of theta is going to equal 1/2, and then we can take inverse cosine of both sides. So we'll take cosine inverse of 1/2, and that will equal theta. Now that one we happen to know, or at least I happen to know off the top of my head. If you want to calculate, theta has to be 60 degrees. So again, now we go back to our unit circle. We have to consider multiple solutions. So 60 degrees on a coordinate grid would look something like this. Okay. Now what we're looking at, again, we're looking at a cosine. So what we're noticing is that the x-coordinate of this is 1/2. That is what we know. So this is 1/2, the base of our triangle. Now that's not the only angle that has that same x-coordinate. If I drop straight down, this triangle would also have an x-coordinate of 1/2. So we can think of it as this will be negative 60 degrees, because we're looking at similar triangles, or we can think of it as this is 300 degrees, and we've talked about cosine in the previous video. So ultimately our solution would be theta can be equal to 60 degrees plus or minus any multiple of 360 degrees. If I go a full rotation or 2 full rotations, I still land at the same spot. Or we can do negative 60 plus or minus any multiple of 360 degrees. And don't forget to write that in this case, n is indeed an integer. It's worth mentioning that it has to be a whole number. If I had 1/2, well then I'd only be going 180 degrees, which would cause a problem. So secant and cosecant, you solve with sine and cosine. The only difference with a cosecant is that writing it as 1 over cosine, you'd be writing it as 1 over sine. Other than that, it's the same thing. Once you've solved for one of the angles, go ahead, make your unit circle, and ask yourself, okay, if it's a cosine, what other triangle has that same x-coordinate? If it's a sine, what other triangle has that same y-coordinate, the height, in that case? And it would be just like doing sine and cosine. So if you need a refresher, check out that video.